Astronomers have discovered an extremely cool object that could have a particularly diverse history. Although it's now as cool as a planet, it may have spent much of its youth as hot as a star. Called WISE J0304-2705, the object is a member of the recently established Y dwarf class, the coolest stellar temperature class yet defined, following the other classes O, B, A, F, G, K, M, L, and T. The current temperature of the object is 200 to 300 degrees Fahrenheit, or 100 to 150 degrees Celsius, which is intermediate between that of the Earth and of Venus. However, the object shows evidence of a possible ancient origin, implying that a large change in temperature has taken place. In the past, this object would have been as hot as a star for many millions of years. Only 20 other Y dwarfs have been discovered to date. Amongst these, WISE J0304-2705 is defined as peculiar due to unusual features in its emitted light spectrum. Astronomers can determine many characteristics of an object from the light emitted by its spectrum, including its chemistry. This newly discovered dwarf spectrum suggests that it may have a composition and/or age characteristic of one of the galaxy's older members. If WISE J0304-2705 is an ancient object, then its temperature evolution would have followed through an understood series of stages. During its first approximately 20 million years, it would have a temperature of at least 5,100 degrees Fahrenheit, or 2,800 degrees Celsius, the same as red dwarf stars like Proxima Centauri, the nearest star to the Sun. After 100 million years, it would have cooled to about 2,700 degrees Fahrenheit, or 1,500 degrees Celsius, with silicate clouds condensing out in its atmosphere. At 1 billion years of age, it would have cooled to about 1,800 degrees Fahrenheit, or 1,000 degrees Celsius, so cool that methane gas and water vapor would dominate its appearance. And since then, it would have continued to cool to its current temperature, barely enough to boil water for a cup of tea. Although the temperature is similar to that of the planets, the object is dissimilar to the rocky Earth-like planets, and instead is a giant ball of gas like Jupiter. WISE J0304-2705 is as massive as 20 to 30 Jupiters combined, which is intermediate between the more massive stars and typical planets. But in terms of temperature, it may have actually taken the journey from star-like to planet-like conditions. The reason that WISE J0304-2705 undergoes such extensive evolutionary cooling is because it's substellar, meaning its interior never gets hot enough for hydrogen fusion, the process that's kept our Sun hot for billions of years. And without an energy source maintaining a stable temperature, cooling and fading is inevitable. The International Discovery Team, led by David Penfield from the University of Hertfordshire, and including Carnegie's Yuri Beletsky, identified the Y dwarf using the WISE Observatory, a NASA space telescope that's imaged the entire sky in the mid-infrared. WISE went into hibernation in February 2011 after carrying out its main survey mission. However, by popular demand, it was revived in December 2013 and is continuing to observe as part of a 3-year mission extension. Having identified WISE J0304-2705, Penfield's team made crucial ground-based observations with some of the world's largest telescopes: the 8-meter Gemini South Telescope, the 6.5-meter Magellan Telescope at Carnegie's Las Campanas Observatory, and the European Southern Observatory's 3.6-meter New Technology Telescope, all located in the Chilean Andes. The team commented that the ground-based measurements were very challenging, even with the largest telescopes, and that it was exciting when the results showed just how cool the temperature of the object was, and that it was unusual. Penfield says that WISE gives us wonderful sensitivity to the coolest objects. With 3 more years of observation, scientists will be able to search the sky for more Y dwarfs and more diverse Y dwarfs. The work is published by monthly notices of the Royal Astronomical Society. With the independence for nimble pursuit, Carnegie scientists tackle some of the most profound challenges in modern science, fundamentally changing what's possible for us, our planet, and our universe.